This next example is an example of a hidden quadratic, and there are going to be many times in the next 2 years or in your whole methods course where you're going to come across different forms of hidden quadratics. So getting used to looking for those patterns is really worthwhile. So what you're going to notice is with a normal quadratic, you would have ax squared plus bx plus c, and you'll notice that the power, we have an ax squared plus bx plus c equals 0. The power of the bx is 1 and the power of the ax squared is 2. So it's double the size in the a rather than in the b. Now if we have a look at what we've been given here, you've got a quartic, so you've got 4x to the power of 4 minus 35x squared minus 9. And the thing to notice is that the power in front for the a term is double what it is for the b term. And that lets you know that it's a hidden quadratic, and we're going to use a bit of a technique to help us to solve this. So let's have a write and see. 4x to the 4 minus 35x squared minus 9 equals 0. And what we're going to do to make our lives easier is we're going to say let x squared equal k. Now if you don't like k, you can use any other letter of the alphabet, it doesn't matter. But then what we have is we actually have 4k squared minus 35k minus 9 equals 0. And it just becomes a normal quadratic that we can solve. So now we can say in the form ax squared plus bx plus c equals 0. And remember that we're looking for our a times c. So in this case, our a is 4, our b is our negative 35, and our c is negative 9. So a times c, well, 9 times 4 is negative 36. And to get to 35, we're going to have to go with 1 and 36. So let's rewrite that as 4k squared minus 36k plus 1k. Okay, so negative 36 plus 1 gives me negative 35. And now I'm going to factorize by grouping, so I can take out a 4k there. I'm left with k minus 9. And I've got my k minus 9 over there. I can take out my k minus 9 and I'm left with 4k plus 1. All right, now I have my null factor law. And by our null factor law, we know that k equals 9 or k equals negative a quarter. And now comes the little trick, because we are not solving for k. We've been asked to solve for x, okay? But we know that x squared is equal to k. So our next little step just says, well, but x squared equals k. So therefore, x squared is equal to positive 9, or x squared is equal to negative a quarter. All right, but now we weren't asked to solve for x squared. We were asked to solve for x. So we're going to take the square root of each of these. So x has got to be equal to plus or minus square root of 9, which means x is plus or minus 3. So that one works okay. Our problem comes in with this one. X squared is equal to negative a quarter. Well, we can't find the square root of a negative number in methods. So therefore, we're just going to say that we're discarding this. It's not a valid solution. Discard as x squared has to be greater than or equal to 0. And we can just draw a conclusion that says Therefore, x is equal to 3, or x is negative 3.